For this week, we have section 2.3. We're going to be looking into interest word problems. For the interest word problems, we're going to be using our compound interest formula. The compound interest formula is A equals P times 1 plus R over N to the power of NT. So we're talking about a compound interest formula. So when we talk about A represents the amount in the account after some T years. So basically what this formula does, it helps us find the future value in your account after a certain amount of time, and we're measuring time in years. P, it's the principal or amount invested. So this is the initial amount that you're investing into your account. And T, of course, is time, and kind of already mentioned it, we measure time by years. Where R is your annual rate and interest. And a lot of the time, well, all the time, when we're plugging in our R, when we're plugging in our rate, we need to show it in a decimal format. And finally, N represents the number of times compounded per year. Forgot how to spell for a second. Okay, so here's our formula. A equals P times 1 plus R over N, all to the power of NT. So basically your future value in your account is calculated by taking your initial amount, your principal, multiplied by 1 plus your rate over the numbers you are compounding per year, raised to the power of the times you're compounding times the number of years you're putting the money into your account. So let's look at a couple of examples here. So let's say we have Karen, who just received the amount of $10,000 and plans to place all of the money in a savings account. The savings account pays 5% when compounded quarterly to help, and she's doing this to help her son go to college in 3 years. So our goal is to find how much money will be in the account in 3 years. So we're using our compound interest formula. So we're using A equals P times 1 plus R over N to the power of NT. So we need to be able to identify what everything represents. So it says Karen just received $10,000. So that's the initial amount. So RP represents the initial amount. In this case, P represents the $10,000. This savings account is paying her at a rate of 5%. So we show 5%. We have to show 5% in a decimal. So remember to move your decimal places twice. So we write it as 0.05. And she wants to put in the money for the next 3 years. So we know time equals 3. The other piece of information we need is N, which is the amount of times we're compounding the account per year. As you can see here, compounded quarterly. So here is where N comes in. So the word quarterly means 4 times a year. So that's how we identify our N. Now we can go back to our formula and we can replace everything we know. So we know P is 10,000, 1 plus, we know R is 0.05 over N is 4. Everything here raised to the power of 4 times 3. Here's my advice. When you're trying to solve this one, there's different ways you can approach the problem. One way of doing it is taking it step by step. So first, simplify the inside. So in your calculator, you will put in 1 plus 0.05 divided by 4. And we get the amount of 1.0125. And here we have 4 times 3, so this is going to be raised to the power of 12. And you have to follow the order of operations. So now we take the parentheses and we have to raise it to the power of 12. So you take what we found here, and now we have to raise it to the power of 12. So you see how we get a bunch of numbers after our decimal. Go ahead and keep a lot of your decimal because you're not allowed to round until the very, very, very end. So we have 10,000, and I'm going to go ahead and keep 1.16075545. So you have to keep a lot of those. For this type of problems, we cannot round until the very, very end. And now, if you're doing it in your calculator, our next step is to multiply by 10,000. So you can just take what we found and multiply it by 10,000. And that's how we get the amount of 11,607, and we're talking about money, so we don't even have to tell you how many decimal places. You should already know the money rounds to 2 decimal places. So we have 545, so that means we're going to round to 5. So that means after 3 years, with the initial amount of 10,000, compounding 4 times a year, for the rate of 5%, at the end, Karen is going to have 11,607. So that means her money grew by about $1,600. That's what this means. So let's do another problem just like this one. Let's say now we have Ross who placed $8,000 into his credit union account, paying 6% compounded semi-annually. And we want to know how much will be in Ross's account in 4 years. So this is a good place to pause the video, go ahead and give it a try, exactly how we did the one before, and come back to the video and double check your answer. So we're going to use our compound interest formula. So we have A equals P times 1 plus R over N to the power of NT. Always go ahead and write your formula first because it's a lot easier to plug into your formula if you already look at your formula here. So I know the easier one we can identify is P. Our initial amount is 8,000, and we can see that our rate is 6%. So when we write it as a decimal, we have 0.06. We know our time, it's 4 years. And here's the part where it says compounded semi-annually. So we have to understand what the word semi-annually means to understand what N is equal to. Semi means 2, so that means we're compounding twice a year. So we go back over here and we plug in our 8,000. 1 plus R is 0.06 over 2 to the power of 2 times 4. And you can continue to do it part by part. So you will take care of the inside the parentheses first. So we will take care of 1 plus 0.06 over 2. So we end up with 1.03. We raise it to the power 2 times 4 can simplify to 8. So now you take 1.03 raised to the power of 8. And we end up with about 1.26667701. Make sure you're keeping a lot of your decimal places. And we continue, so we are rounding, so we get about 10,134.16. So remember, money rounds to 2 decimal places. So that means he grew his money by about $2,000 after 4 years at a rate of 6% when compounding twice a year. The other way you can go ahead and do this problem, you can go ahead and plug all of this in at the same time in your calculator. You just have to be very, very careful of how you plug it in. So we have 8,000, 1 plus 0.06 divided by 2, all to the power of 2 times 4. So you can plug it out all at once, and you can see that we got the 10,134.16. So most of your If we're working on our major quiz, most of our grade is going to come from this. Make sure you understand how to set it up. Make sure you understand how to solve it this way. But the most important part is being able to set up the problem.